Hello friends, welcome you all on our today class. And our today topic is Boolean expressions and functions. Boolean algebra is algebra of logic. It deals with variables that can have two discrete values 0 and false and 1 and true, and operations that have logical significance. The earliest method of manipulating symbolic logic was invented by George Boole and subsequently came to be known as Boolean algebra. Boolean algebra has now become an indispensable tool in computer science for its wide applicability in switching theory, building base electronic circuits, and designing of digital computers. Now about Boolean functions. A Boolean function is a special kind of mathematical function. This is the f colon x n of degree n, where x is equal to 0 1 is a Boolean domain and n is a non-negative integer. It describes the way how to derive Boolean output from Boolean inputs. Let us see an example. Let f a b is equal to a negative b negative. This is a function of degree 2 from the set of ordered pairs of Boolean variables to the set 0 1, where f00 is equal to 1, f01 is equal to 0, f1 is equal to 0, and f00 is equal to 1. This we will clear in the next coming examples. Boolean expressions. A Boolean expression always produce a Boolean value. A Boolean expression is composed of a combination of Boolean constants that can be either true or false. Boolean variables and logical connectives. Each Boolean expression represents a Boolean function. Example: A, B, C is a Boolean expression. Boolean identities, double complement law, negation and brackets through negation of A. Complement law, A plus negative A is equal to 1A plus negative A is equal to 1, that can be OR form, and A dot A, we can say this AND negation A is equal to 0, that is AND form. This is the idempotent law, identity law, dominance law, commutative law, associative law, absorption law, simplification law, distributive law, De Morgan's law. These are the laws. Next is canonical forms. For a Boolean expression, there are two kinds of canonical forms. The sum of min terms SOM form, the product of max term also known as POM form. The sum of mindstorm SOM or sum of product SOP form. A minterm is a product of all variables taken either in their direct or complemented form. Any Boolean function can be expressed as a sum of its one minterm and the inverse of function can be expressed as a sum of its zero minterms. Hence, f, the list of variable, is equal to list of 1 minus minterm index, and f negative list of variable is equal to list of zero minterms. This see here in this table form. The A, B, C term, and this is the minterm. If all are 0, A, B, C, both three are 0, then this is the M0. If A0, B0 and C is 1, value 1, then this is M1. And if A0, C0 and only B is 1, then this is M2 and this is M3 if A0 and BC are 1. In this way you can continue. This is the example, you can understand. The product of max terms POM or product of sum POS4. A max term is addition of all variables taken either in their direct or complemented form. Any boolean function can be expressed as a product of its zero max term, and the inverse of the function can be expressed as a product of its one max term. Hence, f list of variable in this way. Example, and our next topic is logic gates. Boolean functions are implemented by using logic gates. The following are the logic gates. First is NOT gate. A NOT gate inverts a single bit input to a single bit of output. It says very correct. If A, then the NOT gate will be in this way of A, and if B, NOT gate is negative B. If the value of A is 0, then the NOT gate value is 1. It means opposite to A value. And if A is 1, then opposite will be 0. It means NOT gate will be, output will be 0. Next is AND gate. And AND gate is a logic gate that gives a high output only if all its input are high. Otherwise, it gives low output. A dot B is used to show the AND operations. Here A dot B. This dot is AND. The value of A is 0 and B is 0, then A and B, it means A dot B or A and B, the value is also 0. If A is 0, B is 1, then the A and B will also be 0. If A is 1, B is 0, then A and B also 0. Then in the terms of if value A is 1, value B is 1, then A and B will also be 1 in this form, you can see here. Next is OR gate. An OR gate is a logic gate that gives high output if at least one of the input is high. A plus is used to show the OR operations A plus B. Then this is the OR. Then this is also known as A or B. If the value of A is 0 and B is 0, then A or B will also be 0. If the value of A is 0, B is 1, then the value of A or B will also be 1. In this way, A is 1, B is 0, value is 1, A is 1, B is 1, then A or B is also 1. You can see that if both A and B are 0 0, then this will A or B will be 0, otherwise it will be 1. Next is NAND gate. A NAND gate is a logic gate that gives a low output only if all its input are high, otherwise it gives high output. मैं आपको बताना चाहूँगा कि नैंड ये जो गेट है NAND, इसको आप सिंपल तरीके से इस तरह से लर्न कर सकते हैं कि आप इसको बोलिए 1 मिनट के लिए एन। यहाँ पे देखिए AND, इट मीन्स ए, ये जो डॉट हुआ करता था एंड के अंदर, बी। अब सिर्फ आपको इतना करना है कि इससे पहले आपको नोट गेट लगाना है। ये एन जो है ये आपका नोट गेट ही है। ओके, ये देखिए सेम सिंबल है यहाँ पे भी आप देखिए, बस बाकी आपका सिंपल हो जाएगा। 0, the value of A is 0, B is 0, then A and B is, and the बाहर से एंड नोट लग गया इस पे, तो then it will be 1. This is the you can learn next step by in this. For next is NOR gate. And NOR gate is a logic gate that gives high output if both the inputs are low, otherwise it gives low output. ये देखिए इसमें भी वही बात है, ये OR गेट होता है और इसके बाहर जो है वो नोट गेट लग गया है, then this is known as NOR gate. Okay, A is 0, B is 0, then NOR will be 1 0 0 and 0. It means if only values are low 0 0, then it will be 1, otherwise it will always be 0. Next is XOR, exclusive OR gate. An XOR gate is a logic gate that gives high output if the inputs are different, otherwise it gives low output. ये देखिए A 0, B 0, then A X exclusive OR B will also be 0. You can follow these below steps also. XNOR, exclusive NOR gate. An XNOR gate is a logic gate that gives high output if the inputs are same, otherwise it gives low output. If the inputs are same, it means 0 0, then it gives the high output 1, and if 1 1, then it also give 1, otherwise 0. Okay, if the both inputs are same. Simplifications of using algebraic functions. Problem: minimize the following boolean expression using boolean identities. If f is ABC, then ABC in this form, you can understand it. And the given solution is in this way. I will hold the screen for some time so that you can draw these in your rough paper and exercise easily, and you can do the exercise easily. This is the problem 2, and this is the solution. Those students who are preparing for their bachelor degrees and master degrees examinations, that this video is very suitable for them. And those students who are preparing for the competitive exams like as a UGC net sets and for other exams, this video is also helpful for them. Next is K map or Karnaugh map. The K map, introduced by Maurice Karnaugh in 1953, is a grid-like representation of a truth table which is used to simplify Boolean algebra expressions. A Karnaugh map has 0 and 1 entries at different positions. It provides grouping together Boolean expressions with common factors and eliminates unwanted variables from the expressions. In a K-map, crossing a vertical or horizontal cell boundary is always a change of only one variable. See this example. An arbitrary truth table is taken below. A and B both are inputs 0, then A operation B is W. Next is X, Y, Z. Now we will make a K map for the above truth table. देखिए कैसे बनाते हैं. This is the A and B, 0, 1, 0, 1. W, X, Y, Z. अब आप यहाँ पे देखिए, if the values is A0, यहाँ पे बताता हूँ आपको, A0, B0, then output is W. यहाँ पे अब आप ऊपर देखिए, A0, B0, then A operations B is W. It means इस लाइन के जो नीचे आप कोई भी वैल्यू लेंगे और ऐसे ही आप ऊपर लेंगे तो उनका जो भी कॉम्बिनेशन आता है वो आपको आउटपुट के रूप में दिखाएगा. नेक्स्ट आपको लेना है कि A is 0 and B is 1, then the output is X. ये देखिए यहाँ पे, ठीक है. इस प्रकार से आप ले सकते हैं B0 A1 and B1 A1. Next is example number 2. Now we will make a K map for the expressions negation A B plus A negation B negative, and in this way. Simplifications using K map. K map uses some rules for the simplifications of Boolean expressions by combining together adjacent cells into single term. The rules are described below. Rule number first: any cell containing a 0 cannot be grouped. Okay, first you should write down this on your paper so that you can do the practice easily. Okay, wrong grouping. Rule number 2: Groups must contain 2n cells and starting from 1. Wrong grouping. Next rule is third. Grouping must be horizontal or vertical but must not be diagonal. हॉरिजॉन्टल हो सकती है, वर्टिकल हो सकती है, लेकिन डायगोनल नहीं हो सकती। देखिए हॉरिजॉन्टल में है जब तो ओके है, वर्टिकल में है तो भी ओके है। दिस इज द हॉरिजॉन्टल and this is the vertical and this is diagonal, which is wrong. Group rule number 4. Group must be covered as largely as possible. This is insufficient grouping. This is the proper grouping. Large जितना भी आप एक साथ कर सकते हैं उसको कवर करना चाहिए अगर वो बन रहा है तो। If one of any cell cannot be grouped with any other cell, it will act as a group itself. Okay, proper grouping. Rule number 6. Groups may overlap, but there should be as few groups as possible. This is also proper grouping. Rule number 7. The leftmost cell can be grouped with the rightmost cell and the topmost cells can be grouped with the bottommost cells. ये देखिए this is the problem. You can pause the video and write down on your paper, and this is the solution. So friend, this was our today class. If you like this video, please like on the like button, share with your friends. एंड दोस्तों अगर आप इस चैनल पर नए आए हैं तो हम आपसे रिक्वेस्ट करेंगे कि आप इस चैनल को सबसे पहले सब्सक्राइब कर लीजिए और जो बेल आइकन है उसको भी दबा दीजिए ताकि जब भी मैं कोई नया वीडियो हमारे चैनल पे अपलोड करूं तो उसका जो नोटिफिकेशन है वो आपको सबसे पहले मिले ताकि आप वीडियो को बहुत ही जल्दी देख पाएँ। धन्यवाद।